Got it. Hello everybody, welcome to the Robust Engineers. In this video, we are going to see how to apply the releases and what is the concept of releases. First, we will see the concept of releases. Okay, for that, I will draw some figure on my whiteboard. Okay, suppose this is the column, this is another column. Okay, this is the third column over here, this is the fourth column over here. Okay, this is the column. Now I'll draw the beams. Okay, since it is column to column connect this beam, I'll draw this beam over here, draw this beam over here. Okay, now I'll change the color. This is the prime. This is the primary beam. For the secondary beam, I'll change the color to black. Okay, this is my secondary beam. I will write the sizes of the beam over here. For example, B1 as 230 cross 700. Okay, now we have this beam B2 as 230 cross 700. Okay, now we have this small beam over here. This is a secondary beam. We have B3 200 cross 500. Okay, so this is the sizes of the beams over here. Okay, this is B1. Okay, now what is the bending moment? These are the fixed beams. Okay, and these are connecting the column. They are the fixed beam primary beams. Now what would be the bending moment of this? The bending moment would be WL square by 12. For the dead load and live load, we are checking WL square by 20 for the mid and WL square by 12 at this support. Okay, similarly this for this beam also WL square by 12, WL square by 24 and WL square by 12. Okay, now this is hogging moment at the support and sagging moment at mid support at the mid of the beam. Okay, now due to this hogging moment, we'll require some steel. Okay, I will draw the steel requirement of steel with green. Okay, we'll require some steel over here due to the hogging moment. Yeah, for the bending moment we require steel over here. For the hogging moment we require steel over here. Now this steel, we have to lap this steel. Okay, we have to lap the steel to the in the column. So we will lap this steel. What is the standard value as per the IS code? They have given the table, but what we practice for ease in construction, 50 into the diameters of the bar. Okay, we're considering it as the standard value for all the time. Although IS 456 has given the different values for tension and compression bars as well as for the different grades of bar, okay, different diameter of the bars, the formula has been given. But for the standard practice and the confusion, to avoid the confusion inside, we generally follow 50 times the diameter of the bar. For example, we have the diameter of 20 dia bar. 20 into 50 will roughly, we have to lap this 1000 mm if we are going for ordinary detail. For ductile detail, we have to multiply it with the 10 times the diameter of bar in addition. Okay, but in our case, assume that we are going for ordinary, then we have to go for 1000 mm lapping into the columns. Okay, so it is possible for us to go 1000 mm because we are making our lap in the column itself. So it is quite possible for us to the 1000 mm lap of this bar into the column. But what I'm going to tell is, delete this everything, just a second. Sorry for that, because I'm using this whiteboard after a very long time. I will delete all these things. Okay. Now, suppose we are not releasing. Releasing basically means to release this moment. Okay, we have to release this moment over here. We will release this moment over here. We will release this moment over here. Okay, we'll release our moment over here. We'll release our moment over here. So what will be the bending moment? It will act as a beam supported by a pin joint or a, okay. So we have only as we have studied in SFD BMD that for the pin joint we have this bending moment of WL square by 8. So this same condition will get to generate over here as WL square by 8. Okay, so this is basically why we are providing the releases. Okay, but now if we are not providing the release, then what would be the bending moment? The bending moment would be same as that of the fixed, as we have seen in the columns. So this bending moment would be this WL square by 12, WL square by 24, WL square by 12. Okay. Now, for example, this beam, we are getting the diameter of bars at 16 mm. Okay. Now we have to lap this 16 into 50. So it is roughly around 800 mm. Okay. For ordinary detail we are doing. Okay. Although for this secondary beam, we are going for ordinary also only. Okay, we are getting 800 mm ka development length. But the problem is with the size of the beam. We have only got 700 mm depth of the beam. We cannot provide 800 mm depth weld. Sorry, 800 mm LD in this beam. So for that reason, to avoid this confusion, we are providing the releases at the support to avoid the hogging moment. Hogging moment are avoided in this case, as we have studied in a strength of material. Okay, so for this reason, we are avoiding the moment, hogging moment, then we apply the releases over here. Okay, now I'll share my etab screen so that you can understand how to create this uh, okay, this is the model which we have previously applied the stiffness modifier. Now where we can apply the releases. Okay, first I will turn off this modifier labels. Go to, you can go to assign, clear display assign. Okay, now this beam can be released because it is a cantilever, and this beam can be released, this beam can be released. Okay, this beam can be released, this beam can be released, this beam also can be released, this beam can be released. Okay, these are the secondary beams. Some of the example I am taking. Then you have to look at the structure properly and apply the releases. Okay, now go here, assign frame release, or you can go here, assign frame, then you have the release of partial fixity. Okay, now we apply releasing on major as well as minor moment, minor as well as on the major moment. We cannot apply only on the major axis. We have to apply on both the direction, minor as well as on the major. Since we are applying on both the side, we have to, since this beam can be released from start point and can be released from the end point, so we have to apply start and end and then apply. Okay, this beam has been releases. For some cases, for here you can see that we cannot apply these releases on the column. Okay, so we have to apply at the end position only, because this beam is resting on this beam only. So for that reason, we have applied at the end. Okay, so basically these are the concept of releases. Okay, thank you for being with us. uh, Subscribe our channel for more videos like this.